Right, there we go. So hi everyone, welcome to Toronto Data Workshop. This week is a very special week. We have Vincent Arel-Bundock joining us from University of Montreal, where he's an associate professor. Vincent's kind of like the guy that I would like to be when I grow up. He's written an awesome book on quantitative methods. He writes all these amazing research articles, and he's put together a whole bunch of R packages that I use most days. So my first introduction to Vincent was that somebody said, you need to start using the country code R package. And I'm like, sure, I'll start using this. Who is this political scientist guy? Like, what would he even know about R anyway? So I used that package and it was like fairly great. And then I couldn't work out marginal effects for some models. Those of you who have taken courses with me will know that that's a common issue for me. And so then there's a marginal effects package. And then I had to like make some tables about my analysis. And now there's the model summary package. So Vincent, it's an absolute privilege to have you here, and thank you so much for agreeing to talk to us.
This is too kind, and such a great event, and I'm very feel very privileged to be here. It's awesome. Okay, let me share this. Okay, so feel free to interrupt me at any time. Also, to make these slides, I use this this really great package called kableExtra that someone in the room has made. All right. So initially, the talk was going to be what model summary taught me about R package development, and then I put these slides together and I thought about it. And honestly, I'm not sure I have learned a lot of lessons, and I'm not a pro of the R package development strategies, and I honestly I don't feel super qualified to comment on that. I'll still say stuff because I'm a professor, and professors like to talk in general, so the lack of qualification has never stopped me. But what I want to do today, before telling you what I think I have learned and what I still don't know, is do a sales pitch for all these things. So the first one is Rdatasets. Maybe some of you have seen that. It's, I think, pretty cool. Then model summary. That's what I'll spend most of my time on. And then a little bit about marginal effects, and then some lessons. If we can do Q&A after that, that would be great. But if we have time, maybe some people would be interested in learning a bit about Broom, which is an awesome package, and some nesting stuff you can do with it. But that's if we have time, and it will be the organizer's choice. So here we go. All right, so Rdatasets, what is that? Well, so as many of you might know, there's a lot of data sets that come pre-packaged with some either R, the base R distribution, or just some extra packages. And this is all great, but what I did here is I wrote this like 20-line script to scrape them all and put them on a website. So if you're someone who's teaching, or if someone who's developing packages, or just wants some data to play with, go to this website. There's 1,400 free data sets with all the documentation. So this is what I'm going to use here to give you some examples. So examples of model summary. So this is what you can do with this package, model summary. There's a bunch of tables here. It illustrates, I think, nicely the range of stuff you can do. So you can have just typical regression tables with your coefficients and your standard errors and some highlighting. You can do this in, so I think the scientists among you recognize the LaTeX output here, right? But there's also the markdown. There's some plots you can do, and then you can do crazy stuff like replacing all your intercepts by squirrels. So this is model summary, and I'm going to show you a few of these things in detail here. All right, so the first thing to note is that in model summary, there's basically two broad families of functions. The first one does data summaries, and the other one does model summaries. So these are distinct. But all of these functions have basically all the same arguments. I've really tried very hard to keep the number of arguments very limited so that it's easy to learn and also consistent. That was really important to me. So the first one is the Skim function, data summary Skim, which I have completely stolen from this wonderful package called Skimmer, which I really recommend because they can do a lot of really cool stuff. Like you can do Skim by group with them. So even if you like model summary, go check them out. They're awesome. So this is the Palmer penguins data set. So what you do is you load it in memory with read CSV, and then you just call this data summary Skim. And then you get this awesome table there with all the basic information and this nice histogram. This function will work as is, regardless of the output format. So you're not going to have the histogram if you're outputting to a Word document, but if it's PDF or if it's HTML, you'll get all this nice stuff. The second data summary function that I should introduce is the balance function. So if you're doing experimental work, this is often really useful, right? So here I have the male and the female penguins, but you can think of a treatment and a control group. You're going to get the mean and the standard deviation, and then some differences in means. And there's support for all sorts of stuff like clustering and blocking. Using the estimator package. I don't know if you know this one, but it's a nice one as well. So first function Skim, then the balance, then there's this one correlation, which you can do a lot of stuff with. Now I'm introducing some of the arguments. They're going to be the same arguments for all these things. So method is of course correlation specific. So here we're doing the Spearman correlation, but you can always add a title with just like this. And you have a nice little table, correlation table. You can also feed it your own functions. So if you have a function that takes a data frame and returns some matrix, a square matrix, you can also treat that as your correlation. So it's pretty flexible. All right, going really quickly through all this. Because the first ones were easy, but this is now getting into more complicated and more powerful territory. So the other ones, so data summary, Skim, balance, and correlation can be thought of as templates, right? So these are the things that we're going to use really often. So we have a dedicated function for these things. But if you don't like this, or if you need something more complicated, then we also have just the data summary full stop function. And this is super cool. So it's just a wrapper around the powerful tables package. So it's a simple wrapper, but it uses all the same arguments that are in all the other functions of my package. So it makes things simple. And it uses a really interesting formula syntax. So this is something you have to learn. I'm going to spend just a couple minutes on this because it's worth it. So we're going to specify the structure of our table using this formula. So on the left side of the formula, right? And so in R, you have this tilde sign. And on the left side of the tilde of the formula, we're going to have the rows, and on the right side, we're going to have the columns. So I can put anything on the left side or the right side. It could be functions on the left side and variables on the right side, or variables on the left side and functions on the right side. It doesn't matter. This is just going to control what appears on the rows and what appears on the columns. So what I'm saying here is that on the left side, on the rows of my table, I want these two variables, flipper length and body mass. And then on the right side, I want these functions. So I want the mean, I want the standard deviation, and I want the maximum. So you can already imagine that table, right? So on the rows, you're going to have these two variables. The plus sign says that they appear one after the other. And on the columns, you're going to have the mean, the standard deviation, and the max. So this is going to be a 2 by 3 table, right? What you can do here that is very nice is that the function accepts arbitrary functions, right? Data summary can accept any other function. So you can define your own function like this, range. So this is using sprintf to do a range with some nice brackets. So we're going to feed it any variable x, and we're going to create a bracket with the min and the max of this variable. So now we can enhance this the formula we had by just adding range to it. And since I've defined it before, I'm going to have a new column that says range. And now this is where it gets really fun. So we have the same formula as before, but now we nest these functions inside one of the variables. So the variable sex has two values, right? It's male or female penguins. And I'm going to nest all of this using the star, the asterisk. So before I was saying I want all these functions to appear one after the other, mean, standard deviation, max, range. The plus means they're all at one after the other. The asterisk here means that all of this will be nested within it. So that means I'm going to calculate the mean, the standard deviation, the max, and the range for male penguins, and then for female penguins, and I'm going to display all this. All right, so what does this look like in practice? There we go. So it's the same formula, right? Here, data summary, and then just data. That's my penguins data set. And then I get this really cool table that is exactly what I needed. So like, just to be clear, I'm not taking any credit for this. Like, this is all the tables package, the formula, they do all this. What I do here is that I wrap it to get all the same arguments and to get all the different output formats. So you can export this to LaTeX, you can export this to HTML, to Word documents. So it's just kind of a standardization contribution that I'm making here. So this is super cool, and you can define any function. Yeah, so I kind of love this. All right, so this is the data summary. We can now move to the model summary part, which is the name of the package. And that's really what I started with. So we're going to play with the drag racer data set, which has information about all the seasons of RuPaul's Drag Race. And so these are I'm just running the data summary Skim, right? So it's all pipeable, so you can do all this stuff like this, right? So that's kind of nice. And we have a bunch of information like the rank of each contestant in every episode. We have the MIS. I see that's a dummy that says whether a contestant was voted Miss Congeniality in that episode. That's the number of the episode in the season, whether someone was eliminated, etc. So I'm going to estimate a model, right? This is just a linear regression model. Everyone knows this formula here. Right? This is very simple. The dependent variable is the rank, whether someone ranked well in that episode, whether they won that title, mini challenge winner, and then the miscongeniality here. So what the basic function of model summary is simple, right? We just run this, we just put the model in here. So this is a linear model, but of course it works. I don't know why I say of course, but it works with over 100 different model types. Thanks to the broom package and the parameters package. So we get the typical regression table with the standard errors in parentheses here and all these goodness of fit statistics. All of this is all customizable, so you can change the statistic in parentheses, you can change the names, and I'm going to show you a bit of that now. So this is yeah, I see that Rohan loves the defaults. No stars. You're a no stars person? Yeah. All right. Okay. So this is the model summary, one model, but of course you can do multiple models. So this is an example where we have an OLS and then a mixed effects models. A bunch more are supported. So what we see here is that I've loaded the library. I've estimated the same linear model as before, and then the mixed effects model. I have stored these models in a list. So that's just a standard list in R, right? And they're just separated by commas. So this is a list, and it's a named list. You don't have to do names like this, but it'll just, in the table, it'll be model 1 and model 2. But if you name them, you'll get the columns here that are nicely labeled. And then you can use some arguments. So we can add the stars. Goff is goodness of fit. And I want to omit any goodness of fit that has the string IC in them. So this is removing the information criteria statistics there, right? And you get this table here with the added stars, the little footnote, and we don't have the AIC or the BIC there, okay? Okay, so this is many models, and we can do way more customization than this. So this is what I like to do for most of my tables. I create this kind of dictionary here with as a vector. Then it's a named vector. So you get on one side, you have the original name of the variable. and then you have what you want to appear in the table. And then I'm going to use this vector in the coef rename argument here. Okay. You can do really cool stuff like this, where I don't know how many people in the audience know the glue package, but it's a really neat package where you put stuff in curly brackets like this, and they will paste it for you automatically. It's wizardry. I don't know exactly how it works, but it's really beautiful. So what this does here, it says that my estimate, what I want my estimate to look like in the table is I want the estimate, and then I want in parentheses, I want the standard error. So if you look at the table, this is what we get here. You get the estimate, and then in parentheses, you get the standard error. And then as the statistic that appears below, you want the confidence interval. So that's what I'm getting here. And you could have multiple statistics. I can have the p-value and the standard error and the confidence interval. All this is possible. There's the vcov argument, which is super powerful and does give you all the heteroscedasticity, consistent standard errors, and all that stuff. It's pretty automatic for most models, and that uses the sandwich package, which I'm sure many of you know. The format that gives you, it says 1 decimal after the dot, and then the title, and then some notes at the end. So this is a table you can make easily. I think this is pretty concise. And also, what I really like about this is that what you see on the screen here is pretty much all the arguments of the function. With this, so if you understand what we see here, you've basically understand the whole package, and you can do really crazy customization with just these arguments. So once you wrap your head around maybe 5, 8, 9 arguments, that's kind of enough to do a bunch of things. So that's what it is. Okay, so now we've customized the content of the table, but we can do way more. So one thing is we can do plots, coefficient plots. And what's interesting here is that we first use model summary with the coef rename argument, but we have here model plot with the coef rename argument. So the exact same inputs gets you a nice plot. Everything is renamed as you would expect as previously. So it's all pretty consistent and easy to learn, I hope. Also, there's like a billion examples on the website. So go to the website and look at it. One word about the output formats. So what you can do is you can save your tables to file directly. So if you have something like this and it looks like a file name with an extension, model summary will automatically detect the file type and will save the table accordingly. So this is a Word document, obviously, LaTeX file. You can also save them to images. You can save them to HTML. You can also get just the raw code. So if you want the raw HTML for some reason, you can do that. This is super neat. So if you want to customize the look of the table, so model summary doesn't actually draw the table for you. Model summary extracts the information and puts it in a data frame. What we then do is send that data frame to some external packages to draw the actual table. In R, there are many packages that can draw tables. I've chosen 4 here, but there could be support for more packages in the future. But so these are 4 really nice packages. So GT, if someone here hasn't played with that yet, it's really nice. So GT, kableExtra, FlexTable, HuxTable. These are 4 different packages to which model summary can output. So if you choose output GT, it will create an R object that is fully compatible with the GT package, and which you can customize with all the functions of the GT package. So by default, we're going to get an object that's compatible with kableExtra for reasons. And we can use all the functions in that package to customize the table. So for example, the types of customizations you can do is this. So you can have in this picture on the right side, you have the colored row, the colored numbers. So for those who play in LaTeX a bit, you know it's always a pain to do these spanning column labels, right? So kableExtra is going to do all of this for you. And the neat part is that if you're writing an R Markdown document, then model summary will automatically detect the output format, and you actually don't even need to specify output at all. It'll just detect everything, and regardless of what you knit to, you're going to get a neat document. All right, so just to give you an example of what you can do with kableExtra functions. So these are two functions from the kableExtra package: add header above and row specification, maybe. So I load kableExtra. I create a list with 4 different models. 2 models are going to be normal and 2 models are going to be Poisson. And then I do the usual. So this is exactly the same command I ran before. We're going to add stars. We're going to omit everything. So the gof omit accepts regular expressions. So those who know regular expressions know that this is something that will match everything. The dot is any character, and the star means that we're going to accept any character an unlimited number of times, or 0. And then coef rename. But the key here is that we pipe all of this. We pipe the model summary table to these functions from the kableExtra package: add header above and row spec. And thanks to these, we're going to have these spanning column labels to say that model 1 and 2 are Gaussian and model 3 and 4 are Poisson. And I'm going to highlight this row here. So this is really useful when I give talks about research. For example, I want to highlight some coefficients that I think are more important than others. This is really neat to do that kind of stuff. Okay, so this is kableExtra. Just want to say one word about this other package, marginal effects. So this is a transition here. So marginal effects is really in development right now. It's a new package that I published just I don't know, a few months ago. And it's supposed to be a one-stop shop to do all these things. Adjusted predictions. So that's just the predicted outcome of your regression for some fixed values of the regressors. Contrasts. So what happens to your outcome if the regressor goes from 0 to 1 or from blue to yellow? Marginal effects. These are the slopes of your regression equation. And then this one here, marginal means. So the pitch here is, for those who know the e-means package or the margins package, it's basically that, but it supports more models, and I've tried to make it a bit easier to use. So these two packages are really, this e-means in particular is super powerful. It does a ton of stuff I can't do. And margins was really the inspiration for my package. So all credit to them, but I felt there was room for another one. So this is the basic thing. So you load your package, some data, and then you estimate this. And then you do marginal effects and then summary, and it gives you the average marginal effects or the pairwise contrast for all your variables. So that's neat. And you can do these plots. So you're plotting adjusted predictions. You're plotting the slope, how the slope changes based on some condition. So check it out. Marginal Effects also has a website and everything. Send me questions, feature requests. I'm still, my level of motivation for marginal effects is still high. So don't hesitate to contact me for anything. All right. So this is marginal effects and model summary. I now want to ask the question that I posed in the title. Did I learn anything about R package development? Not sure, maybe. But these are a few of the thoughts that I had while trying to answer this. So the first one is, if you're going to develop your own package, start very small, right? That's the first piece of advice. So in my day job, I'm a political scientist and I study international relations. So I deal with a lot of comparisons between countries, and had to deal as a grad student with a lot of different country codes. So Algeria sometimes is ALG, but sometimes it's DZA. And you want to merge these data sets with different incompatible codes. So I just wrote this little function in 2009, and I released a package called country code. It does one simple task. And it's been pretty stable. We now cover something like 50 different codes and a bunch of different country names and such. So that was a great start, actually. It was super simple, one task, it worked. It was a great introduction to our package development. It's surprising to me, but it's had a long life. And at the last conference I went to, someone bought me a beer because they use country code. So it still, it still does its work. But I get beer, but I also get bug reports and feature requests still today, almost 15 years later. So if you release an R package, you might have to support it for a long time. And quitting on your users is not super cool, I think. So start small and start with something you can manage, and don't develop 15 packages would be my recommendation. So ideas for things that you might want to look at. So let's say you do all these plots in different projects and you want them to be pretty and uniform. You can develop a package that has your own ggplot2 theme, like that's an easy one. Developing your own personal list of functions that you carry across projects is really useful and nice. So some data cleaning stuff. So one of my first things is when I started grading, I had to normalize these grades to make sure that I didn't have too many 0% and too many 100% and looked a bit normal. So I had some functions to normalize grades. So start with something small is my advice. The second thing that I noticed while developing is that the R community is just amazing. So I told you about this thing, country code. It was just on CRAN for several years. And then I decided to put it on GitHub. And then these two guys, Nils and CJ, came in, and CJ did amazing work, like speeded it up by like 1000x. And then Nils came and rewrote the entire regex compendium by hand, the 200 regular expressions, and just improved them like a crazy person. It must have, this is hours and hours and hours of work that he did on this. And now the package is much better thanks to them. So we wrote this paper for the Journal of Open Source Software, and I have never met or spoken to either of these people. And we have this paper together, which I think is pretty cool. So the community is great. People will contribute if you put your stuff up. So invite contributions and try to be nice to contributors, and it works. All right. Another point is that you have to be keenly aware of your market, I think. So in general, I would argue that fractionalization of the ecosystem is pretty bad. So if we have a package that already does something, you don't want to create another package that does the same thing necessarily, or at least it shouldn't be your first reflex. So always ask the question, is there already a solution for this? And do some market research first. Then if you find something that exists, try to improve that before, because there's probably some reasons where there are constraints, some things you haven't thought about. So in my case, there was nothing like country code. So I looked at it, there was nothing, I created a package. Then I was using TechRag for years, and I've actually made some contributions to the TechRag package. So I've made pull requests and they were accepted, but then I ran into limitations that I just couldn't jump over. So I decided to do my own package, but that came after, years of using this one and also making contributions to it. I had kind of a good idea in my head of what should be done. And then same thing with margins. So this was my go-to package for marginal effects for years. Thomas Sleeper, who was a very prolific R package developer, has been doing this for years. I've made some contributions to it, but now he has less time to work on this. So it seemed like the best path forward was to fork it. Well, not fork it, but rewrite it. But it's just like, don't try to reinvent the wheel if you don't have to. All right, use all these testing and tooling things. There's so much greatness out there that makes your life easier as a package developer. I won't go over all of these, but look them up. They're really cool and they're super helpful, all these packages. Because if you just go to the developing R packages, developing R extensions documentation, it can be very overwhelming. So use the automated stuff. It forces you to adopt good practices anyway, so it's all great. So one tiny thing is tests are amazing. Tests are really great. Nobody wants to write the tests, but they're going to save you. So what I do is I never actually use scratch files. Like I'm never going to open a temp.r file to try to debug or to develop a new function. I'll always start developing new features or reproducing bugs in a test file. So that way I know that my new test, my new function, my new bug fix will already have a test as soon as I'm done with it. So I'm writing immediately in test files. That's kind of nice, I think. Okay, so this is like, I don't want to start a big, this is kind of a controversial thing in the R Twitter, but there's this website called tidyverse.org, which makes the argument that lightweight is the right weight. So I have this this package called WDI for World Development Indicators, which relies on the World Bank API. And I get bug reports literally every time their server goes down. It's like, it's really annoying. It's not my user's fault. I totally understand, and I've tried to make error messages, but it's just I get the bug reports, and it's really hard when you rely on someone else's internet for your package to work. Same thing, model summary relies on kableExtra, which is awesome, but it relies on basically all the tidyverse. So my own test, because of this kind of twin dependency, my own tests are always broken. GitHub Actions can't install like one of the 72 packages or whatever. When there's a deprecated function, I always get new warnings. So it's not a big deal, and it works. And look, I love the tidyverse. I teach it, I use it. It's all great, but it is a pain. So just be aware that there are trade-offs here. So try to minimize the dependencies if you can. Don't reinvent the wheel. If there's something better than what you can write, of course, use that. But be willing to accept some downsides. And go visit this. It's kind of a it's I don't know, like they're trying very hard to make the point very intensely, and that's great. But look it up and then take some leaves. Okay, so the last point that I want to make about our package development is about this question. So why are we doing this? So for me, really, this is a fun hobby, right? So when I was a kid, I did some programming when I was a kid because I liked it, and this stayed with me. So it's a fun hobby. I love it. I wouldn't do it if I didn't love it. But at the same time, like I get no money out of this, zero. I get no credit at work. Like I was talking to Rohan before this, and of course, like it was in my tenure file, but like I'm pretty sure nobody looked at it at all. So I get no credit. Fixing bugs often feels like a chore. And then bug reports, I love them. I love the feature requests, but some people are really rude. Like they write to you and they say, oh, I need this in 2 days. Look, I have other stuff to do. I'm happy to help you out, but like, yeah. So this is the bad part of it. And the good part is that I am, well, it's good and bad, but I'm not a great person in general. I love flattery. So when you have champions and like people who invite you at talks like this, or people who retweet the package, or people who write you an email to say, look, this is great, without any request, like just say this. So like happy users are wonderful, and it's super nice to get a pat on the back once in a while. So my suggestion to you is to write an email or tweet to your favorite package developer today. Just say, I love your work, it's good stuff, and that will make their day. And it's pretty cheap for you, because that's really the only pay that most of us get, right? So like we should, as users, I think we should be more aggressively thanking people. But I think more generally, beyond just saying that people are great, I think it would be nice for us collectively to think about ways to give developers more incentives. I'm thinking here mostly about academic researchers who can do this. Like we have time, like we do research, but we have time that we could invest in this. So there's this really big untapped resource of time and skill, because we're in a stage right now where there's so few incentives that we almost certainly have an underproduction of public goods. So I'm not sure if it's about changing the norms over software citation. I'm not sure what kind of other incentives there should be. It's like, it won't be about money, and like for academics, that doesn't really matter anyway. But like, we really have to have a strong think about how we can incentivize this stuff. Okay, so I have other stuff that I can come back to, but maybe it's a good time to pause and see if there are questions and discuss. What do you think? Or should I go through the stuff?
Yeah, maybe just, it looked like there was just a few slides, so we could just.
Yeah. Okay. Yeah. So this is so earlier I was saying that model summary supports something like 100 models, and the reason it can do that is because of this awesome package called Broom. So I'm sure a lot of you have heard about it, but for those who haven't, I think it's worth going through just a little bit. So the basic problem that Broom is trying to solve is how to extract and manipulate information from statistical models in R. So you have this, right? You estimate a linear model and you do summary, and you have this printout, and it's really not clear how you get stuff out of it. So we know there's the coef function. We know there's this, there's other ways, but what this does is it gives you a standardized way to extract and manipulate stuff coming from basically any kind of model you can estimate. So it's a standardization of the interface that we deal with. It gives you 2 or 3 functions that work the same way all the time when you use any model. So it could be a mixed effects model, it could be a logit model, it could be like some kind of a categorical outcome model, doesn't matter. Broom will always extract it in the same way. So how this works is this. So you have your model, and then you call this tidy. And then tidy will produce a data frame, a table, with 1 row per parameter and 1 column per statistic that we're estimating. And it's always like that. So you can really count on it to be consistent. It's almost always like that. And then, so that's the first function. And then there's glance here. That's always useful. And that gives you things like the R squared or the information criteria. So glance always produces a data frame with 1 row. And that's quite neat, because you can do glance mod. And then since it's a data frame, you can just do your $sign and your R squared. So you extract it there. So you can see, I think that this is really useful. So for example, if you want to do simulations, you can just tidy all your output, and then you get a really nice data frame with all your results, regardless of the kind of model you're trying to estimate. So under the hood of model summary, this is really what's happening. So I'm calling tidy and I'm calling glance in order to extract the information. So one cool thing that you can do with tidy from the Broom package is that you can use this for doing nested or group operations. So this is data.table, which is fast. It's really great. It's powerful. There's no dependencies. The developers, it's super stable. Doesn't change much. I love it. So what this does, data.table, is it provides you an alternative data frame structure that you can do operations on by group. Essentially, you can do a bunch of things, but this is one of them. So it really looks like a standard data frame, right? It's the same thing. And so here it's going to be the first one is going to be rows as usual. The second part is going to be columns. And then you have this argument there by. So remember, we are dealing here with the drag racer data. This data is structured by season, so I can do operations for each seasons. And what I'm doing here is SD is a shortcut for I don't remember what it means. It's basically the data frame for that group. Okay. So what I'm doing here is I'm estimating a linear model of elimination on the mini challenge winners for this data frame, which is each group. So that means that I'm going to estimate this regression in each season. Okay. And then I'm going to use tidy to extract the information from the model that I've estimated within each season. And with just this single line of code, I've estimated the linear regression for each season. I've extracted the data, and I've outputted a nice data frame like this. And if you look at the two first rows, this is the intercept and the coefficient for the first season. This is the intercept and the coefficient for the second season. You have the season identifier here, and you have the estimate and the standard error. So this is, I think this is really awesome. You can do group operations like this in one row, and everything works great thanks to data table and tidy from the broom package. So this is essentially the same thing that you can do with nesting in tidyverse or dplyr. So here you use the nest by. Oh, SD is subset of data. Yeah, that's possible. Thanks, Ryan. So what we do here is we nest by. So when you use the nest by function from dplyr, what you're going to get is an identifier for your group on which you're nesting. And then this is a list column where each entry is a subset of the data, right? So in season 1, I have 63 rows. In season 2, I have 120 rows. So this is the subset of my data for each of these seasons. Now what I can do is I can create a new column. It's called results. And in my results, I'm going to have this thing here. I'm going to have my regression model. I'm going to have the tidy. So I'm extracting all the information from my regression model. And then I have the list. This is just kind of a container to fit it nicely in this list column here. And then finally, I can unnest the results. So I have this this pipe here that gets me essentially the same thing that I got with data table in this one line that I showed you. But again, you have the season 1, the intercept and the coefficient, and you have all the information you need. So Broom is super cool because you can combine it with these other powerful tools, and it works with any model type. It's a really great project, and it's also the code in Broom is super simple. So before I was saying that if you're interested in package development, you should start small. Broom might be the best place for you to start. So if there's a model that you don't know about, that you don't know how to extract information from, and there's no standardized way to do it with Broom right now, go look up the repository. There's many examples there, and it's super easy to contribute a new method to extract information from the model that you like. So that's a really good entry point, I think, for new contributions. And that's it. So email me. I like people. I like to interact. Yeah, I have this book that's free. Go to my website. Si vous parlez français, le livre est gratuit. Et si vous avez des questions dessus, ça me fait plaisir d'y répondre. Merci à tous.
Thank you very much, Vincent. Just an incredible presentation. We'll stop recording in a moment. I'll just ask one first question. So if folks have questions, then raise your hand. But just first question, do you have any books that you recommend in addition to your own?
Yeah, many books. You told me you were going to ask this, so I prepared. So these are 2 books. I don't know if I recommend them, but I just bought them and I'm super excited to read them. So I guess that works, right? So the first one is this. So it's the Memoirs of Amartya Sen, who's an economist, says here Nobel Prize winner, but also a moral philosopher, super interesting person. Had a really interesting life as well. So apparently the memoir is amazing. So I just got it, super excited. And then the other one, which is more for the stats crowd, I guess, for you, is this that I also got. So you all know this graph, right, from the Tufte book, the Napoleon, but this is, there's way more where that came from. So the Minard has a lot more really beautiful maps and graphs. And this is the full archives from the Collection de l'École Nationale des Ponts et Chaussées. So this, I just leafed through it and it's beautiful. So I haven't read, but I recommend.
One-click ordering means I've just ordered that. That's amazing. I'll stop recording and